Okay, well, good afternoon, evening, good morning, I guess. Welcome to 6.3a. This is the first of 6.3. We're going to do, again, more polynomials. We're factoring polynomials, especially of the form ax squared plus bx plus c right here. So we're going to factor those. Now, a in this section, 6.3. In section 6.2, I guess we did a is equal to 1. In section 6.3, this section, we're going to talk about either a is equal to 1 or a is not equal to 1. So we're going to give a couple different choices. And this is, section 6.3 is probably going to be a little bit more kind of real life, because now we have to kind of decide what we have to do to factor this when a is equal to 1 or a is not equal to 1. And again, if we're given an a equal to 1, in other words, x squared, is 1x squared, then we know that a is equal to 1, and we can kind of make some easier choices. But if a is not equal to 1, we're going to find some more possibilities that we have. And this is going to be called the trial and error method, because we're going to, again, start with this, ax squared plus bx plus c as our product. We're going to find two different factors of the form something x plus something in parentheses, and then another parentheses with x, something x plus something, or something x minus something. And those two factors are going to multiply together to give us our product. So let's take a look at our steps. Alright, so now we've got section 6.3. Here's our smartboard presentation. We're going to be, again, factoring trinomials. Trinomials are the form of this form here, ax squared plus bx plus c. We've got three different terms. And we're going to be using the trial and error method. And I prefer more trial than error, but a lot of times, and that's just a little joke, but we're going to have to do, sometimes when we get larger and larger numbers, we're going to have to do some trial and error and cross off some possibilities and just go through different factorizations. So again, if we're factoring trinomials, we're given a trinomial, which is a polynomial with three terms. And here's the form that we've got: ax squared plus bx plus c. We've got a trinomial because we've got three parts. This is going to be our product, and we're going to find two factors that multiply together to give me this trinomial. So we're going to have to find something like this: x plus something and x plus something in parentheses. And those two are going to multiply together to give me that ax squared plus bx plus c. So if we're given a trinomial, then we have to find those factors. In 6.2, like I said, we did polynomials with a leading term of, or a leading coefficient of 1. In this section, we're going to work on a little more complicated ones. And this gives us a little bit more choices, more opportunities, I guess, for factorization. So let's go through a couple steps. We kind of did a little bit something like this, something a little more simple, I guess, with section 6.2. Here's how to factor ax squared plus bx plus c. And now this is going to, again, 6.3 is going to give us something where a is not equal to 1. So we have to modify those steps that we took in section 6.2. But we're gonna always, for any kind of factorization, we're going to do this kind of make our life easy. Number one, factor out a greatest common factor. If there's anything that's common between ax squared and bx and c, it's going to be most likely a number that would be common between a, b, and c. But it could be something of the form ax cubed plus bx squared plus c times x, where we'd have to factor out an x, and that would be our greatest common factor. So that could be a possibility. But in other words, we always have to factor out a greatest common factor if there is one. That makes our life easy. We also have to make sure that if there's a negative 1 in front of the x squared term here, in other words, if that a here is negative, then we have to factor out a negative 1. And that makes our life easier because we can factor out, when we factor out a negative 1, that makes a positive, and it switches to b, and it switches to c sign. But that makes this, that a term, then a positive number, and that makes things a little easier as well. And 1a, I guess, is to make sure that we have all the terms in descending order. So there's my step 1a. All right. So greatest common factor, factor out a negative 1, put it in descending order so that it's in the format of ax squared plus bx plus c. In descending order means that you pay attention to the exponents that are up here, 2 and then 1 and then 0. Step number 2 would be to write the factors like this. Here's a factor, there's one factor, there's another factor, write the parentheses. And this is real similar to what we did in 6.2. The only difference is we didn't have in 6.2, we didn't have a space here because we knew that a was equal to 1, so we had 1 times 1, and we really didn't have to have a space here. But now a is not going to be equal to 1. It could be something like 2. So this could be 2 and 1. This could be 6. It could be 2 times 3. So here's our new factors here. So this is going to be something that's new for section 6.3 that we're doing right now. Step 3 is nothing new. We have to determine the signs. So if we determine the signs, again, if C is going to be positive, if this number is positive, then we have to then the signs in the parentheses are either both positive, and I'm going to cross that out because that should go down here. That should be negative. And again, I tried to modify this in my Smartboard, but it just wouldn't modify correctly. And I've got a section. This was created in Smart, I think 10.0, and this is now I'm using 11.1 or something like that. So it just doesn't work together well, which is really too bad for Smart. But anyway, we have to determine the signs. These signs here for our factors, inside the factors, we have to determine the signs. If C is positive, in other words, if that number is positive, then this number times that number multiplied together to give me C. So that's either both positive, that one, a positive times a positive would give me positive, or a negative times a negative would give me a positive. And that's again if C is positive. If C is negative, and I guess we'll take a step back here, and then the sign on B tells you if they're both positive or both negative, because this one plus that one has to add up to that one. So if B is positive, then this and this would be positive, because they'd multiply together to give me a positive number, and they'd add up to give me a positive number. If B was negative, then they have to be both negative, because they'd multiply together to give me a positive number. Negative times a negative would be a positive. Negative plus a negative would give me a negative if B were negative, because the B will tell you whether these are both positive or both negative. All right, if C is negative, if this number is negative, and don't worry about this, we'll go through a lot of examples soon. But if C is negative, then the signs in the parentheses are opposite. So if this number is negative, then these two numbers multiplied together give me that number there, that's C. So either it's going to be positive times a negative, which will give me a negative if C is negative, or a negative times a positive would give me a negative as well. And that's only if C is negative. So if C is negative, then these are opposite signs for these two numbers here that we're going to factor out. So this step 3 is not new for section 6.3. Step number 4 is new. So this is going to be the newest part, I suppose, for section 6.3, because the product of these first terms, this term times that term, or if we're factoring out here, this term times that term, has to equal my ax squared. Because if we FOIL this out, if we FOIL it out, this times this is going to give me my first term, and that's going to give me ax squared. So we've got the x times the x already. It gives me the x squared. The a has to be factored to that one times that one to give me that one. So that step number 4 is going to be something new. So we have to factor now that ax squared to give me factor pairs that go into right here and right here. Step number 5 is not new. Product of the last terms is in the factors is C, because again, if we FOIL this out, if we FOIL up here, this is going to be a sign, that's going to be a sign. So that number times that number gives me C. So the product is going to be C. So then we have to just write out the factors of my C, and those factors have to go here. And that's nothing new. Step number 6 is where we get the trial and error. This right here is going to be the trial and error part. Trial and error, because with some of them that we start out with, in fact, the first one we start out with on the next page is going to be pretty straightforward. We're not going to have to do a whole lot of error to get our trial, to get our factorization up here. When the numbers for A and C get larger, then we have to start thinking, we might have to do a little more trial and error. But basically, this right here, step number 6, is going to give us our trial and error. Step number 4 is new as well, where we have to find factor pairs of a. So let's go through maybe just an example here of just a generic term here. If I've got 2x squared plus 7x plus 6, well, you know what? The factors of a have to go here. So right here, I'll make this blue. Here's my a. This number times that number has to give me 2x squared. This number times that number, again, if we're foiling things out, the last terms together don't have any, or the last terms multiplied together don't combine with anything as like terms to get us that 6. So this 6 is factored out over here. And then when you know the factors of 2 and the factors of 6 and you write them all down, then you can start doing the trial and error. Step number 7 is nothing new. It's basically a check. So when we get our factorization up here, when we finally figure out what this number and that number should be, what the signs should be, what the numbers here should be, then we have to do our FOIL to say, did I factor it correctly? So let's take an example and walk through those steps as well. So you know what? Here's my 2x squared plus 7x plus 6, which is exactly what we did back here, 2x squared plus 7x plus 6. Let's just factor that out. So step number 1, 2, I guess, let's go back and go through our list here. Step number 1 is really kind of make our life easy. Factor out a greatest common factor, a -1 from a if it's present, and then put it in descending order. So let's make sure that it's just in descending order. Descending order talks about the exponents. So here's 2, here's x to the first power, and x squared means the power is 2. X to the first power means the power is 1. X to the 0th power is equal to 1, and that we don't really write it here, but we have to understand that it's there. So this already really is in descending order. So it's 2, 1, 0. Okay, so our descending order, we've kind of done that. Let's see. Factor out a -1 if we need. There's no -1 here. That is not a negative number here. So we don't have to worry about factoring out a negative number. So it's already kind of given to us like that. Factor out a greatest common factor. Makes our life easy because it makes our trinomial a lot smaller. Is there any common factor between 2x squared and 7x and 6? Well, there really isn't, because you could factor out a 2 from here, but you can't factor out a 2 from there, so there's no numbers to factor out. And you could factor out an x from here or an x from there, but there's no x here to factor out as a greatest common factor. So step number 1, and I guess really 1a also in descending order, makes our life easy. It's already been given to us as probably the easiest way, or the most convenient way, or the simplest way it can be written. So step number 1 is write the factors out. Just like our previous 6.2 section, we write the factors out and we say, all right, well, my factor has to be this times that. And I know there's going to be an x here and an x here, and there's going to be a number here and a sign and a number and a number and a sign and a number. So here's where we start with. There's our factorization shell, let's say, or skeleton. Step number 3 is determine the signs. We did this in section 6.2, and again, if C is positive, and here's our C is positive. If it's positive, then this, hang on a second, we'll make it green. Then this number and that number have to be either both positive or both negative, because they multiply together in our FOIL, that F word that we can use in math. They multiply together to give me that number there. So my 6 is positive. That means that either both of these are positive or both of these are negative. And how do we determine? We have to say that, well, they're going to add up to this number here, this 7. So the 7 is positive, so they both have to be positive. So I'll put that one as positive, and I'll put that as positive, because they multiply together to give me positive 6. Positive times a positive gives me a positive, and they add up to a positive as well. When you do the FOIL and you find your inside and outside terms, those numbers add up to the like terms of positive 7. Alright, so we've done our signs. So there's step number 3. Step number 4 is finding that product, or finding the factors of ax squared. And really we're finding the factor pairs of a, which are going to go in right here in front of the x. So right here, we'll make this blue. here is a number, and here is a number. Now, it could be that those numbers are 1. In fact, in section 6.2, they were 1 because 1 times 1 gave us 1, because our limitation in section 6.2 was that a was equal to 1. So now, though, this number here, that 2, in fact, probably the 2x squared, has to be factored into the blue sections. So, because again, if we FOIL it out, our first terms, this x times that x, have to multiply together to give me 2x squared. We've got already the x's as in our frame, in our skeleton. So now we have to just factor out that 2. Now the 2 is factored into either 2 times 1 or 1 times 2. So it really doesn't matter. I guess my preference is putting 2 there and 1 there. You could easily put the 1 over here and the 2 over here. But again, if we're multiplying this out, if we're FOILing out our two factors, the first times the first is going to give me my first leading term. 2x times 1x gives me 2x squared. If we get into larger numbers, like the 10x squared, we'll have to kind of look at that and say, well, it could be either 1 times 10 or 2 times 5. But for right now, we've only got 2, and the 2 becomes either 2 times 1 or 1 times 2. I prefer to put the larger number here, but again, it's your choice. So there's our factorization of the ax squared term. Let's go back and take a look at step number 5. Step number 5 is nothing new. The product of the last terms in the factors is c. So we write out the factor pairs of c. So let's take a look at what we've got for c. Here's our c in green, and we take a look at our factor pairs of 6. What are the factor pairs of 6? Well, it could be 1 times 6. It could be 2 times 3. And it could also be 3 times 2 or 6 times 1. Now these right down here are repeats of these up here, but you have to repeat these down here just because if you put 3 and 2 in there, it's not going to be the same, especially when you multiply the inside terms and outside terms, and we'll see that in just a second, as if you put 2 and 3 in there. So if you put 2 and 3 in there, it's different from 3 and 2. So it is the same factor pair. 2 times 3 is the same as 3 times 2 to give us 6. But the location here is going to be different because if we put in, for example, if we put 2 in here, it'd be 2 times 1 x gives me 2x, and 3 times 2 gives me 6x, versus 3 and 2. If we put 3 and 2 in here, it would be different. 3 times 1 would give us 3, 2 times 2 would give us 4. So let's take a look at these examples and say, now comes the trial and error, because now we've kind of written our factor pairs of c, and step number 6 is play with the combinations that we got here, 3, 4, and 5, which was the signs, the factor pairs of a, and the factor pairs of c. So now we really don't have to play around with the positive and the positive, because those are not going to change. The 2x and the 1x, you could switch 2x and 1x over, but they've both got positive signs here, so it's not going to make a difference here. So now the only trial and error we do is figuring out whether it's 1, 6, 1, 6, or 2, 3, or 3, 2, or 6, 1. And the way we do that is to just put numbers in here. And this is, at this point, you'd probably say, let me pull out my pencil and my eraser, because we might be doing some trial and error. In fact, that's what we'll be doing here. So we'll put in our first factor pairs, 1 and 6, and see now if this is a correct factorization. The way we do that is to FOIL it out. First term would be 2x times 1x gives me 2x squared. Sounds good to me. The inside terms and the outside terms are really going to be what's going to tell us a correct factorization or not. Because we've already done our 1 times 6 gives us 6, and 2 times 3 would give us 6 as well, and 3 times 2 would give us 6 also. So we've kind of factored these. As long as we limit ourselves to these green pairs, we don't have to really double check our 6 multiplication. But the inside and outside terms are what we have to worry about. So our inside term is right there, outside term is right there. We kind of make a smiley face and say, all right, well, 1 times 1 gives me, 1 times 1x gives me 1x. And then the outside terms would be 2x times 6x would be, again, if we're FOILing it out, this would be what we'd FOIL out. 2x times 6x gives me 12x. And if we combine those like terms, that should add up to my b. But 1x plus 12x equals 13x, and that's not equal to 7x, so we throw that one away and say that's not a correct factorization. And then we go up and say, all right, well, there's where my trial and error comes in. And I say, now I go back and I say, let's try a different trial and error. Let's try a different pair. Hang on a second. We'll make it green. Let's try a different pair and say maybe it's 2 times 3. Because 2 times 3 would give me 6. And now we say, does it work out? And we do our FOIL, but we really kind of limit ourselves to our outside and inside terms, or inside and outside terms. 2 times 1x would give me, and that one's not correct, 2 times 1x gives me 2x. 2x times positive 3 gives me 6x plus 6x. And if we combine those in our FOIL, it would be 2x plus 6x gives me 8x, and that's not 7x. So we have to throw that one away, and we throw the 2 and 3 pair away, and we say, let's go and pull out our eraser again, and say we're going to erase that one, and hopefully get to a new one, and get a good pair here. So the next one, logically, would be 3 and 2. So let's put 3 in here, and 2 over here. And again, this is going to be different from our 2 and 3, because remember our 2 and 3 gave us this one. 3 and 2 will give us a different sum. So let's take a look at what 3 and 2 give us for inside and outside terms. 3 times 1x gives me 3x. 2x, and that would be, I guess, a plus 3x. 2x times 2, or plus 2, gives me a plus 4x. When we add up those as the like terms in our FOIL, plus 3x plus 4x gives me 7x. So you know what? That looks like a good factorization. And that looks like a good factorization. And what we should do is probably now go through our FOIL and say, if we FOIL it out, will that give us a correct factor, or is that a correct factorization? Will multiplying these two products together give us that product, or multiplying these two factors together give us that product? So let's FOIL and figure out what we got. Again, if we FOIL, we go first, outside, inside, last. First term is 2x times 1x gives me 2x squared. Outside terms are 2x times 2 gives me plus 4x. Inside terms are 3 plus 3 times plus 1x gives me plus 3x. Last terms are plus 3 times plus 2 is plus 6. And now we've got to combine those terms, and that's where our outside and inside terms come, and that's where our big check is. So here's our 2x squared. We're combining these like terms here, and 2x squared doesn't combine with anything. Plus 7x plus 6 is FOILed out, is these two factors multiplied together to give a FOILed out product here. And this 2x squared is the same as that, plus 7x same as that, plus 6 is the same as that. And we've double checked our work, and we FOILed our factors, and there we go. So that's what we do. It seems like a lot of work, but it will come a lot quicker as soon as we get more experience. So here's our steps. If you need to, I would say write these out for a cheat sheet study guide. Again, you're not going to be able to use a cheat sheet on the test, but as you're going through things, it's probably going to be a good idea to kind of refer back to this. And this is going to be, again, in our handout as well. No homework for this section because we're going to go through a couple more examples over here, and there will be a homework section for that, or a homework problem for that one. Any questions, bring them to class. Go and check out section 6.3b for a couple more examples and some more trial and error methods.